Geometry Semester 2, this is the 6th unit called Surface Area. It's the 4th lesson within that unit called Surface Area of Hexagonal Prisms and Oblique Hexagonal Prisms Practice. It's on creatormath.com under the Geometry tab. You might have to put in creatormath.weebly.com if you search for it in Google. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from Creator Math. Remember, the notes are in a separate link there. You just click Notes, copy those into the comp book first. Then these problems go in, and you can use this video to help you come up with the solutions. So the instructions are given the following three-dimensional shape. What's the surface area? So interestingly enough, this is a trapezoid. See the end shape? This is a trapezoid, and it's a three-dimensional trapezoid, otherwise known as a trapezoidal prism. There's hexagonal prisms over here. Now that I'm looking at the title, let's see where they are. There they are. So there's hexagonal prisms too in here. The interesting thing of this is that we are let's look at this one. Given the following three-dimensional shape, what's the surface area? If we took this thing and wrapped it, see how we have a long side back there? We unwrap this thing, we'd have a larger rectangle, then we'd have a rectangle or panel for each of these three sides. So something like this. So when we go to calculate the surface area of this, and then maybe there's these trapezoids on the end like this that stick out. Something if we cut this open and unfolded it. Remember you used to do this with pieces of paper back in elementary school? You'd make like a cylinder and then cut it open and unroll it. So what's cool about this is there's a rectangle here. The rectangle is defined by the height, right? The h is this dimension. And the perimeter of this shape defines this entire length. So perimeter times height will give us all this area. Then we just find the area of one of the trapezoids, which is 1/2 base 1 plus base 2 divided by 2. Or I said that, wait. 1/2 base 1 plus base 2. There we go. Let's just say base 1 plus base 2 divided by 2. That's the average of the two bases times the height. Height is the perpendicular height of the shape this way. So we need the perimeter of this thing to get this dimension, and we need the area of one of these, and then we'll multiply it by 2, and we'll have the surface area of the whole shape. They're going to talk about this formula sort of conceptually with us. So the perimeter of the end shape is what we did to come up with this length, times the height of the shape, which is this length. That gives us the rectangle. Adding to it 2 times the area of the end shape. So this is a great illustration of how to find surface area of this shape, and just talking through it sort of explains, you know, sometimes we start memorizing formulas in math, and it really doesn't help us much because we can never remember. But if we can remember the way to unfold it and then think about just coming up with the pieces of the entire thing, then it makes a formula a little bit more acceptable to us. This problem now gives us an oblique, right? When I was a student in high school, I pronounced it oblique, but it's not, it's oblique. It just means that this shape has been moved over. Now notice the top and the bottom, if I could get both my hands here. The top and the bottom of the shape have remained parallel. So the top and the bottom have been slid apart, but remain parallel. So the base, the plane that the base is in and the plane that the base is in are still parallel. These two lines here and here are parallel lines. That's the interesting thing of oblique. It's not just a slanted shape. Oblique has an interesting definition. So notice we have the perpendicular height that is perpendicular to the base here. Perpendicular means 90 degrees. And the interesting thing about this is if we unroll it in the same fashion, we are going to come up with the exact same perimeter of the end shape times the perpendicular height plus 2 times the area of the end shape. This surface area formula is exactly the same no matter whether it is a non-oblique shape or an oblique shape, as long as we are dealing with a perpendicular height. Here, we don't really have to say perpendicular height because there's only one type of height. All of them are perpendicular. Here, we have to be a little bit more careful because oftentimes our brain gets confused and we look at this and we're like, is this the height from here to here? Nope, that's a slant distance that is not relevant for us in this calculation. We need this perpendicular height. As long as we've got that, the surface area formulas for a trapezoidal prism are exactly the same. Now they're giving us a hexagon for the end shape. Hexagon is 1, 2, 3, 4, 5, 6-sided shape. So this is a hexagon on the end. And again, if we unrolled this, see how there's 3 sides on this side and 3 on the back. We would have 1, 2, 3, 4, 5, 6 panels, right? And these panels together make up a rectangle. So if we knew the perimeter of this top shape all the way around, that would be this length. And we have the perpendicular height here, and we can now find the area of this. And then on one of these, we have to have the 6-sided shape here, if I can draw that. 1, 2, 3, 4, 5, 6. Good. And there's another one here. There we go. If we can find the area of one of these and multiply it by 2, we would have all the surface area of this 3-dimensional shape. So sure enough, that's what they're showing us on the last problems and on this one. The perimeter of the end shape times the height of the shape. That would give us this box, this rectangle, all this area. And then 2 times the area of the end shape. So find the area of one of these, multiply by 2, and now we're going to have the surface area of this shape. The next illustrates that even if it is oblique, as long as we're dealing with a perpendicular height, then the formula for calculating the surface area is exactly the same. The perimeter of the end shape times the perpendicular height times 2 times the area of the end shape. Same exact thing as long as we're using perpendicular height. I think that's probably the biggest revelation of this, where it's most interesting for your brain to think about why. How does that even happen? Well, that's the way it happens. And the greatest illustration is when you take a shape like this, fill it up with water, and a shape like this with the same perpendicular height, fill it up with water, and show that the exact same amount of water fits into them, right? The volumes are the same. And then all of a sudden the surface areas that wrap around them are the same. Very interesting. So unfortunately this is a problem set, not that great illustration. Maybe we'll do that at a later time, all right? So what's the surface area? So same thing, perimeter of, okay, so now once they unwrap this, they're going to go a little bit further here. The perimeter of the end shape, the height of the shape, that's going to give us that middle rectangle, this one when we unroll it. And then 2 times the area. So what we have here is the area of a trapezoid is base 1 plus base 2 divided by 2. It takes an average times the height of that shape. So each of these trapezoids, let's draw it upside down. It's like this up here. This is a trapezoid here. That's a trapezoid shape. This is called a base. This is called a base. And I don't care which one you call 1 or 2. It does not matter because you could flip it. And so whichever one is on top is now on the bottom. It doesn't matter. There's a base 1, base 2. So what you have is by adding base 1 plus base 2 and dividing it by 2, we get an average of these 2 lengths times the height of the shape, which again is the perpendicular height of this thing, HT right here. That gives us the area of this shape. And it's 2 dimensions. It's this dimension times this, length times width, or x times y, the x-axis dimension by the y-axis dimension. And that's going to be the area. There's 2 of those, so we multiply this by 2. See it right here? This one here, again, illustrating to us this sort of general concept of surface area repeating over and over. It repeats the exact same way, even though we have an oblique shape, as long as it's still a perpendicular height. So now you'll see perpendicular height in here. Otherwise, it's base 1 plus base 2 divided by 2 times 2 of them times the height and the perimeter of the end shape to give you that area of the larger internal piece. So I think they should have spelled out here, given us a hint. Hint, the area formula. There you go. Hint, the area formula of a hexagon is, it's this down here. It's 3 radical 3 over 2 times a squared. 3 radical 3 over 2 times a squared, where this length here is what defines the a dimension, that side of it. All right, so that's going to give us the area of the end piece. There's 2 of those. And so we have 2 of those times 3 radical 3 over 2, right? Plus, we need to unroll the thing, and so we need the perimeter of the end shape times the height of the shape. Again, the illustration for us is the exact same thing when oblique, as long as we are dealing with the perpendicular height. And I hope you're seeing a pattern emerge here. That's the whole point of the lesson. The whole point of the lesson is to continue to illustrate for us, if we can just look at the perimeter of the end shape, multiply it by the perpendicular height, add to it 2 times the area of the end shapes, we're going to have the surface area of any three-dimensional shape that fits this pattern. Okay, so, and once again, it'd be nice if they put this hint right here on this one, just to always, we don't remember what the area of a hexagon is. So that's it for this lesson. These are the problems associated with geometry. It's from semester 2. It's the 6th unit called surface area, and it's the 4th lesson within that unit called surface area of hexagonal prisms. And it's also got trapezoidal prisms in there too, and oblique shapes of those 2 end areas. Find it on creatormath.com under the geometry tab. Hope it helps.